общем, большинство участников такого совместного семинара, в общем, с давних Киев является одним научным центром, в общем, всемирно известным научным центром по теории вероятности математической статистики. Тут надо вспоминать наших учителей Иосифа Ильича Гейхмана, Владимира Семеновича Королюка и Анатолия Владимировича Скорохода. Вот, и я имею в виду, в общем, вечная память, это и Михаил Иосифович Ядренко тоже к этой списку относится. Вот. Но, в общем, я очень благодарен организаторам, и с вашей стороны, и с нашей стороны, что вы начали очень хорошее дело, и которое, я думаю, будет иметь и будущее, большое перспективное будущее. Мы всегда рады обмениваться научным результатом своими, в общем, и ознакомиться с вашими результатами. Это нам очень будет полезно и будет помогать в подготовке будущих кадров, по вероятности, у нас. Я думаю, и в Киеве тоже. В общем, да. Так что этому семинару желаю больших успехов. Будьте здоровы.
Спасибо. Спасибо. Okay. Since among our participants there are some people who cannot understand Russian, so after academic Furmanov says greetings for our series of lectures, I also want to say some words that, in my opinion, such lectures will be very useful for young generation mathematicians in Uzbekistan, in Ukraine, and I hope that it will be only first step in our deep cooperation with the Uzbekistan Probability School, and hope that after this COVID situation will stabilize, we will not only organize such Zoom meetings, but also we will have a possibility to meet one another. So I think that this is a very nice just beginning. I wish everybody success in these lectures, and I must say that we expect that the survey articles related to these lectures will appear in our journal Theory of Stochastic Processes. So I wish good luck everybody, and let's start our lectures.
Thank you.
Okay, maybe Professor Husanbayev also want to say something.
Нет, давайте представим слово тогда докладчика. Я плохо английский.
Okay, so first speaker is Professor Bakoev, and if he is present, then please, let's start.
Thank you.
Just a moment. Bir. Eshitilyaptimi? Yoqub aka, eshitilyaptimi?
Yaxshi eshitilyapti, yaxshi. Все нормально. Okay.
Okay, good morning, everyone. It's good for me to give some lectures today. If you allow me to demonstrate my desktop, it will be better. I will start my lecture. Can you allow me demonstration? Okay. Ko'rinyaptimi ekran? Yoqub aka?
Ekran ko'rindi, lekin hali prezentatsiyangiz to'la chiqmadi.
Yo'q.
Ekraningiz ko'rinyapti.
Just a minute. Endichi?
Okay.
Okay, today's is my lecture is numerical simulation of the solution of diffusion equation in problems of finance and management. The plan of my lecture is this one, introduction. I will give some things about fundamental concepts of the options. Definition of an option, payoff of the options, and I will start my lecture with the simplest model of in financial market is the Blackshaws Model. You know this one, and then I will talk about numerical simulation in Blackshaws models, and then we will discuss barrier options, Heston model. And I will pay more attention in pricing Asian options using Monte Carlo simulation. And I will talk about Asian options a little bit, and I'll give some numerical experiments. And if we have time, in the next time, I will talk about multi-asset option pricing. In this day, today, I will talk only single about one options. Do you have some questions? No? Thank you. Let me introduce myself. My name is Bakoev, and that's the first one. It is about my education. It's education, Tashkent State University and World Language University and TASIS MBA program. This is my experience. I worked at Mathematical Institute of Academy of Science of Uzbekistan and the University of World Economy and Diplomacy and the Academy of Public Administration, under the President of Republic of Uzbekistan. Nowadays, I work at the University of World Economy and Diplomacy. Is it okay? Okay. Let me. Nowadays is financial market one of the main object is an option. And what is the option? Option are the part of derivative instrument. Derivative are financial instruments that derive the value from the value of other more basic underlying variables. Option is some contract which we can write is this contract and work together, but this is a derivative. Under these options lie another variables, whether we can say the stock, etc. And this as a fundamental option is a European call option or European put option, but for us more interesting learn or do something about exotic options. for which one it is difficult to find the price of these options. You know, the trading options became more popular from 1980. Maybe it's early, but from 1980, it was more interesting, and the financial market is increasing from this year. But it was a classic textbook rule, you know, it is a option, futures, and other derivatives. It's more popular. After that textbook, the financial market or research in financial markets increases. But this book is a fundamental book for derivatives. Okay, options are a class of derivative financial assets of which the value depend on another assets. Call it underlying. Okay, this one. Okay, option may be two types, which two types options are discussed anywhere. It is called call option or called put option. And in order to option give to us the right for buy or for selling some assets, and in concrete time, this concrete time we called strike, strike time, but with concrete prices. These prices we in the future denote by K, and we call this strike. And then we introduced another definition, expired date. We called it T. And okay, we have strike time or expired data, it's a T, and strike price, it's K. All options of the same time, we have call or put, are referred as an option class where the call put is defined as. The call option gives the holder the right to buy the underlying asset by a certain date for a certain price. These options give only right for who has this option. Call options are for buying, but put option for selling. An important relation between the call and put option is called put-call parity. It is if we call this is a C is the price of call option, P is price of put option, S it's the price the value of asset in the period at the time of T, and this called we put-call parity. Okay, I thought about it. And one of the main strategy in the financial market is we have three types of strategy. The first one is in the money. It means when the price of assets more than strike price for call option. For put option, this is a less than strike. At the money, we call S equal C, S equal K. In both cases, out of the money, this one. What is the European option? European option is if we fix it sometime T, we can use our option only in the fixed time. In this case, we call it as the European option. If we have used our option until the fixed time, in this case, we call this the American option. But other options which between European and American option, we can specify it, and we give some names for this option. And now we will discuss and we will pay more attention in European call option, in European options. That's why I'll give some definition of European options. Okay, all right, just okay. In European options, if the for European options, the payoff function we denote by this one. Oh, I forgot, this is ST. Payoff function, it means at the time T, if the price or value of stock more than K, you can buy and sell, then immediately sell your option, your asset. In this case, you have the profit ST minus K. If the K more than ST, then you cannot, you do nothing because it is not profitable for you. In this case, the price or payoff is this one. And for European put option, it is the contrary. If this K is this, you do nothing. In this case, you can sell your options, your assets, and payoff function is this one. Okay. Any question? No? Okay, let's continue. If we analyze the financial market, or we analyze some mathematical model of financial market, we have a lot of parameters in financial market, and a simplest one for Blackshaws model, we use 5 parameters. The first one is the underlying share price. It is we denote by S during our lecture. It is price of the stock. The second one, the strike price K. It is the price which we show in our contract at time T. At time T, the strike price. The second one. Next one is time to expire. It means T minus T. This one. And the volatility of underlying share, it is the sigma, or you can say variance. And the risk-free interest rate is R. Usually this the government announced every year or every some period. This is a risk-free interest rate. These 5 parameters we usually use in Blackshaws, in the market, in Blackshaws model, is the simplest model. But if we have some dividend, if you have to pay some dividend in our assets, in this case, we can include the dividend pay share too. Is it clear? Okay,
okay. Very good. Okay, no problem.
You know, I start my lecture with the simplest model popular model. This is Blackshaws Model, which was developed by Merton, 1973. You know, they have the winner of the Nobel Prize for this Blackshaws Model. That's why I will start with this, and then step by step I will give another models too. You know, in the Blackshaws model, we have the following assumption. The first one is the share price follows a geometric Brown motion or log normal model. It means the price of assets are log normal model or log normal has log normal distribution. The second one, short selling is allowed. Next one, no transaction cost or taxes. It means we discussed its complete market. It means we have no pay taxi, we have no borrow some money during this in this market or in this model. All security are, if it's possible to buy any fraction of the share. It means you have chance to buy or to sell any fraction of the assets. The underlying security does not pay dividend during the life of the derivative. No riskless arbitrage opportunity. It means you have to the same chance to win or to lose. Security trading is continuous. We will discuss continuous model, but it is easy. Oh, we can discuss some discrete model too, but in our lecture we will discuss continuous model. Okay, let us start talk about Blackshaws model. Give the stock price S, which follows this process. This one. This is S is a stock price. Mu is a drift. Sigma is variance or volatility, and W it's the winner process. Or if you discuss, if you follow this, has a log normal distribution. And suppose we denote by VST, it is the price of the option at time t. Price of option at times t. Depend only on S and T time. And you know, using the ethos lemma, we can find the stochastic differential equation for V. Or using this one, you can write the stochastic differential equation. But for V, we can write this stochastic differential equation. It is easy using the ethos lemma. And in order to receive some differential equation for the price of the Europe options, we assume that we have portfolio. Our portfolio we denote by P, which one option, we have one option V, and delta number of underlying assets. In this case, choosing this portfolio, our portfolio is this one. The value of portfolio in this case is the price of and minus this one. And change you can compute. You can write all the differencing, this one, we receive. And is another way we use the formula number in the previous formula, we can receive this one. And here, if we put this equal 0, this part equal 0, it means if delta equal this, or number of assets equal for this one, in this case we receive this deterministic equation. Oh, sorry, this one, equation 11. And the return on the amount of P portfolio in riskless assets, it's this one, R P dt, or it is equal this. And using this, we can receive this partial differential equation for the option price. Or Merton called this equation pricing equation, and this we called Blackshaws model or Blackshaws partial differential equation. In order to solve this partial differential equation, we have to have some boundary values of these prices. This is a famous Blackshaws partial differential equation. Boundary condition on European calls and puts options. At the time t equal in expire time or strike time, expire time, the payoff function will be this one. Maximum s minus k and 0, between 0. And you can analyze when s equals 0, what is this, and etc., etc. For put option, this is boundary value is this one. And you know, we have a lot of articles or a lot of research in order to solve this differential equation with this boundary conditions. And we have some analytic solution of this Blackshaws model, but I will not pay attention for in analytic models, but I will give some algorithm, or I will prepare some algorithm or Monte Carlo simulation for solution of this equation with boundary condition. In order to solve this problem, I prepared some interactive package in Maple, which using this interactive package, giving these parameters, you can analyze and you can find the price options. And here, if you can change these parameters and give the simulation, this is the simulation of the stock price, stock value here. This is if I give number of this one trajectory, and this is the riskless price, PT, riskless price, or PT in our cases, and this is together, just. And if I give the simulation, you can observe, you can monitoring the price or stock price, riskless price, and together. and you can compute the option price here and a standard deviation of this. This is estimation of the option price, and here standard deviation. Okay, and this is some numerical result analyzing. I'll analyze this my algorithm or simulation procedure using the computer using Maple. Here it is this is red one is estimation of the price. It is a call option. This is for put options. This red one is estimation, and this one is blue one is confident. Okay, this is a prediction, and red one I can say it is a confidence interval for price of the options, which depends of volume of the sample. You can see it is a this is a volume of the sample, and this is the price. Okay. In the table, this is a number of volume of the sample, European call option. This is a error, European put option. That's error. Okay. And now boundary volume. Let's go further. It is a more interesting thing. It is a barrier option. Okay, sorry for me, it's not boundary value problem, but it's a barrier option. What is a barrier option? In the barrier option, if the price of assets cross some boundary, we stop. In this case, the equation we can write this one like this is the initial problem, but this in the boundary A and boundary B, the cross and the out of the boundary, we say it is a price equal 0. Barrier option. And we the same thing, we prepare the interactive package for barrier options. Look here, we have two barriers here. This one, the barrier is, for example, this is a barrier, this is a B. If the trajectory crossed this one and we stopped, here we stopped, and this procedure, we have this procedure compute for us the price of barrier options. I said for Blackshaws model, we have analytic solution of the, we can find analytic formula for the option prices, but for barrier option, it's not easy to find the analytic solution of the price. That's why we use this Monte Carlo methods or simulation procedure in order to find the barrier option prices. The same the numerical results for barrier option prices, and this is for the call option, and this is for put options. This is a table, the same like. Okay. May I continue? Dr. Bakoev, is still left me?
Very good. Okay.
Okay. The next one, and I said Blackshaws model is the simplest one, barrier option. It is the next one, which we have some barriers. And the next one is Heston model. Heston, what is the difference between Heston model and Blackshaws model? In Blackshaws model, if you pay attention, we have this drift and we have variance. Variance was a constant. But in real life, in practical process, usually variance depends on time and variance is a random. In this case, we write this Heston model using three stochastic differential equations. It means this one, the first one for the assets price, second one for the variance, and the relationship between two. This we have this one. It is a rho is a correlation matrix. This is for this one using the Ito lemma, etc., like as a Blackshaws model. We can find the price, some differential equation for option prices. For example, I'll give here for European call option prices. In order to find this UTX new, we have to solve this boundary value partial differential equation. Look here, we have here, this is a differential equation, partial differential equation, and we have a initial condition for at t and for x, and we have initial some conditions for the derivative for u, etc. It's not easy, it's impossible to solve this problem analytically. That's why we recommended and we constructed the algorithm of the solution of this problem using Monte Carlo methods. May I continue? You have to pay attention. This is the variance is not constant. Variance is a random. Okay. For American put option, or you can write American put option, and a little bit I can change, and I can write the same the problem for American call options too. Look here. This we have to solve this partial differential equation with condition with these conditions. It's impossible to find an analytical solution of this problem. That's why we use numerical methods. Okay. Look, some numerical results. This one is a simulation of the assets price. This one simulation of the variance. This one is I can say it's approximately the solution of the stochastic differential equation for the asset. This one for the variance or for the volatility with x0 this and etc. Okay. For the model Heston, we have the same, we receive results for European call options. This is for European put options. Okay. This is a numerical result in the table. Okay, do you have some questions or some comments?
Finish it.
No, I can continue if you have no question.
Oh, please, question.
Okay. If you have no question, I will continue my lecture. The next one is Asian options. I told we have two types of options. It is the American option and European option, which depend. It means we can identify these two types of option looking at the time of the using your options. But we have a lot of type options which not for time is depend. It is depend looking at the payoff function. One of the options with Asian options, it is a payoff function. If you pay attention in previous models, payoff function depend only in the last value of the assets. But it is interesting for us to know what was the if we receive the payoff depending during the all times from the beginning until the end. In this case, it will be a difficult, it will be more useful or more practically use this payoff function. Okay, let us consider standard complete market economies. There are two assets traded: BS, it's a B risk-free, and S risky assets. As now you know this one, as we discussed this, and simplest way, if we said mu is a constant and sigma is constant, it's the Blackshaws model. And for risk-free, we have this dynamics for price. This is a stochastic differential equation. Oh, sorry. This is stochastic differential equation. This is an ordinary differential equation. Let's we introduce some variable AT. We call this is a path depend option, path depend contingent clients, or we call depend variable this. We denote by this one. If we denote AT is this is a function which depend the value of asset until t. That's why we can write some stochastic differential equation for this AT. It's this one. And this final payoff function, if we denote by this t strike time. St is the value of assets in at the strike time. This is value of A at the strike time. And if you denote by VST as the price of the options which we are going to introduce or to include, in this case, using the Ito lemma, we receive this equation, or we have solving this Cauchy problem. We can find V as VTSA.
Excuse me, may I ask a question?
Yes, of course.
So you functions mu a and sigma a are given. Are they? Are not they?
In this case, now is as a general, and then I will analyze. I'll giving this mu and sigma. I will find the Asian options. This is a general, not given. In general.
And you write that a is a function psi of s.
Yes, yes.
So you say that assume that a is a solution to the equation 3 with some functions mu a and sigma a, then a is some measurable function of s.
Yes, yes.
Okay.
Okay. Now, in the further, if we become as analyze, it will be clear. Okay.
Okay.
Okay. Now let's start our. Let's look here. Mu s is mu multiplied by s. Mu is constant, and sigma s is sigma multiplied by s. Sigma is constant. Mu and sigma are two non-zero constants. Okay. In this case, you can find what is this? At is this one. And mu r is log this, sigma is 0, and this payoff function is this one. And we call geometric average floating strike call option. If we choose this, and geometric average fixed strike call option, this one.
I'm sorry, I don't see the end of the formula. Maximum of ST and
ST minus, just a moment, ST minus K.
Okay, thanks.
This is okay, just it's my fault. Okay. This one. Okay. After that, if we put this here, this one. The Cauchy problem for price of geometric floating fixed strike call option is here. This one, this partial differential equation with this, and for this is a flag. Just a minute. It's a fixed average floating. This for average floating, and this one for fixed strike. If we solve this equation with this, we can find the geometric average floating call option price. If we solve 6 and 8, no, this one, it is a fixed strike call option. Now, if you pay attention, this this equation, it's not easy to solve, or it's impossible to solve analytically this equation, because it is a ultra-parabolic equation, or somewhere called, this is a Kolmogorov equation. That's why we will find the numerical methods for solution of this problem. In order to solve this equation, we make some transformation, and then in the end we receive this equation with final condition, this one, or maybe this for this one. Okay, using Monte Carlo methods, and I'll give some algorithm of the solution of this problem. That's why, first of all, just supposing the existence of the solution of the problem 9, we use the Monte Carlo algorithm, which offered in our article for the numerical solution above mentioned problem. This basis for the construction of algorithm was the mean value property of the equation 9. It means mean value problem, mean value theorem, a lot of mean value theorem for parabolic, for heat equation we have, but we built up mean value theorem for this Kolmogorov equation, and using mean value theorem we construct the Markov chain, and on the trajectory of this chain we built estimation of the solution of this problem. This is the density of the random vector, number surface unit sphere, and indicator of the set, etc. And let us construct Markov chain, and on the trajectory of this Markov chain, we built up and based estimator of the solution of the problem. That's here. I'll give some formulas for how I can compute the trajectory of this Markov chain. This one. Oh, sorry, I have this. No, the formulas. If you are interested, I'll give the formulas correctly. And from this we have this relation. Means the solution is a mathematical expectation for the next point. Using this one, we find we built up the sequences, some sequences which are estimation of the solution, and I'll prove some theorem, and then I'll I'll give some numerical results for fixed strike call option and for floating call option 2. This is this interest rate, the starting price of the assets, and this the price of the Asian options. This is for fixed strike. This is a bibliography. And thank you. Good luck. If you have some question, please.
Thank you. Да, okay. Very good. Andrei Anatolievich?
Oh, okay. Thank you very much for your lecture. And please, questions, comments.
Ребята, у кого есть вопросы? Наши ребята, пакистанские. Задавайте, пожалуйста, вопросы. Конечно, тематика очень такая большая, конечно.
Ну
Обзор.
да, может, в следующий раз после второй лекции будут уже.
Да.
То тут надо немножко подумать. Okay, I think that maybe questions will be after the next lecture. By the way, the recording of the lecture will be available, and the reference was in announcement. So for those who didn't understand something, there is a possibility to watch this lecture again, and hope to see you next time after a week. Thanks again to our lecture today, Professor Bakoev, and this is the end of our session. Thanks,
Yeah, thank-
everybody.